Today we're talking about scatter plots and lines of fit. So a scatter plot is basically a graph that shows a relationship between two sets of data. The two sets of data are graphed as ordered pairs, which we know are x comma y, in a coordinate plane. And scatter plots can show trends in data. So a scatter plot is more than what we've been seeing so far as perfectly straight lines. You'll see here in this first example, we have a graph of smoothies where looking at this graph and understanding what it's talking about, we're seeing the number of calories based on the number of sugar in grams that each of the smoothies have. So you'll notice in this graph that it's definitely not a linear graph, but there is some trends that we see here. So a scatter plot is more of a realistic graph than a lot of the ones we've been showing so far this year, where we have an exact perfect slope, an exact perfect rise over run. This is definitely showing some things that are happening as the sugar gets higher. You can see that the calories, for the most part, continue to get higher. But it's not an exact science. So a scatter plot is going to be more of our realistic, where you actually are calculating things and measuring things and coming up with an actual graph. If you recall, back in the days, these little notations down here. This little thing here is called a break. A break is when we know our scale on the y-axis, for example, should be very consistent through all the different plots. You'll notice that from 240 to 250 to 260 to 270, I'm going up by tens. But 0 to 240 is definitely not by tens, and it needs to be consistent. So we do this break to kind of jump up to 240, and then we're consistent after the jump. Same thing down here. 0 to 46 is what this first grid is worth, but then after that, each grid is worth 4. So we show that this is a jump. This is not a realistic scale. The real scale starts here at the 4s, just as a refresher. So the scatter plot, as we just talked about, is showing the amounts of grams of sugar as compared to the number of calories in 10 different smoothies. So we have 10 different smoothies information. So again, how many calories are in the smoothie that contains 56 grams of sugar? So grams of sugar would be down here. 56 is going to be in between. So this is really just interpreting what this looks like. And if I just follow my graph up and over, that would give me my first answer. There are 270 calories. So that's just really reading the graph and making sure that we include the label. Okay. Second question, how many grams of sugar are in a smoothie that contains 320 calories? So now I'm focused on the calories here, and I'm going to come across this line until I find a point, follow that down, and that would tell me that there are 70 grams of sugar in that many calories. And then the last question, what tends to happen to the number of calories as the number of grams of sugar increases? So let's just look at that. So the grams of sugar, as it's increasing, meaning all of these ordered pairs, their x values as they go this way are getting bigger. So what's happening, for the most part, to the number of calories, or the y values, as these numbers get bigger? Don't these also get bigger? So the way we're going to answer this is we're going to say the number of calories increase as the number of grams of sugar increases. And that's really all we're going to say for now. Right? We're just going to talk about as one is increasing, so isn't the other one. So the more sugar you have, the more calories you end up with. Now what you'll notice though, again, like I said, this is not a definite linear thing, because for example, right here, 54 grams of sugar in one of our smoothies was 260 calories. In that same amount of sugar, this one had 290. So it's not always going to be the exact same. So it's more of a realistic graph for sure than the kind of models we've been seeing. Example 2. Then we want to talk about things called correlations. So correlations are kind of like those trends that we just talked about. So when I look at a correlation, I'm looking at how is my data, what's it showing? As the x values down here are increasing or decreasing, what's happening to these numbers in here? And we typically will say as the x's are increasing, what's happening to our y's? So on this one, we look at the trend. So do we see a trend as the person's age is getting bigger, meaning they're getting older? Does the number of vehicles that they own change? Well, when they're 20, they have 4. They drop to 30, they might have 1, they might have 5. It's kind of bouncing a lot, okay? So what's going to happen here is that we're going to say there is no upward or downward trend. And what that means is we really can't predict what age 60 is going to show, for example. We can't really predict what 70 is going to show, okay? So the answer to this is no correlation because, BC would stand for because, can't predict. So basically what that means is we're saying no correlation because whether you're 20 or 52, for example, they both owned 4 cars. And at 55, they owned only 3, but at the age of 45, they owned 7. They only owned 1 at 30. So there's not enough information to show that if you get older, you own less cars, or if you get older, you own more cars. So we would say there's no correlation. Now comparing that to this next one for B. As the daily temperature is increasing, we're talking about coat sales, what's happening to the number of coats that are sold per day? Now again, it's not a perfect straight line here, but it's very clearly a trend. As the temperature goes up, the amount of coat sales is coming down. Okay? So how we would write that again is as temp increases, sales decrease, which makes sense. The hotter it gets, you don't really need a coat. So we call this a negative correlation. Now, we don't have a perfectly straight line. We definitely cannot say that we see a negative slope. But basically that's what we're talking about. As the number is going up on the x's, the number on the y's is dropping. So it's kind of like saying that there's a negative slope, even though we can all clearly see that it's not a slope because it's not a constant rate of change, but it is definitely a trend that we can see. Now I just want to add one more in here. So let's call this one C. So looking at the smoothie graph up above, what kind of a trend or what kind of a correlation do we see? Well, if I go back up to this graph, again, as the sugar increases, the calories are also increasing. So when this happens, that's when we would say we have a positive correlation. Again, kind of like a slope, but it is not a slope. It's definitely something that's changing very differently and not exactly the same each time. But we can definitely say, oh, what is going on? Get this back. We can definitely say that it is increasing as the sugars also increase. So those are correlations. So then we want to talk about this thing called line of fit. So when we start looking at a positive or a negative correlation, you can't really do this when you have a no correlation because there's nothing to really correlate. If we have that, we can model the trend in the data using a line of fit. And I think the key words in there is line, because we know that a line is going to be a straight line, and then the word fit. The word fit means something that's going to give us the best representation of this. Sometimes you'll also call these trend lines, but I think most of the time we see the word line of fit. So basically a line of fit is something that we draw right on top of our scatter plot to approximate as much of the data in a nice straight line as we can. So we're going to kind of force it to become linear just so that we can use it to predict things. So looking at this kind of map here, first we make the scatter plot. So we're going to take a table and we're going to make a scatter plot. Then we decide if it can be modeled by a line. Sometimes if it's no correlation, then we can't. But if it is something that we can do, we're going to draw a line that appears to fit the data closely. Now, a couple of key things here. There should be approximately as many points above the line as below the line. Okay? You're not going to hit every point or else it wouldn't be a straight line anymore. Then, knowing what we know about slope-intercept form or point-slope, we're going to write an equation using 2 points and key here on the line. The points that you choose to write your equation don't actually have to be real points from your table. They have to be part of the line that we draw. Okay? And it's really important that we understand that. So you can take any points on the line. So once you have the line set, you don't really care about all the other points that are not on the line. You're only working on points that are on the line. So let's just run through an example here to see if this kind of helps. So we're looking at the table that shows weekly sales of a DVD and the number of weeks since the release of the movie. Write an equation that models, so we're writing an equation that models the DVD sales as a function of the weeks since the release. So that basically tells me when I read that sentence that the sales is my Y, which we can see in the table, and the number of weeks, which would be the independent variable, would be my X value. Once we have that, we want to interpret the slope and the y-intercept of the line of fit. Now notice we haven't really used the word slope in this section because we aren't seeing straight lines. But once we create a line of fit, we can talk about slope because we've made a linear equation, and then we can go from there. So remember, the word interpret is to describe what the numbers mean using the numbers in a sentence. So we've talked about this word interpret. It doesn't just mean the slope is 2. What does the number mean in that situation? So use your slope numbers, use your y-intercept to describe what we know about that number. So interpret is really, really important, and we have to keep making sure we understand how it works. Okay, so here's the table. We see all positives, which would make sense because we can't have negative weeks. We also can't have negative sales. So I'm going to draw, and you should be using straight edge. I wish I could figure out how to do the straight edge here on this, which I don't think I can do. So when I draw this, I'm going to have weeks down here for the X's, and I'm going to have sales up here on the Y's. Now on the Y-axis, looking at my numbers, I'm going to go by 2s. Because I can see that it will fit in perfectly there. And my weeks will just go by 1s. Now, we're not always going to get this perfectly accurate. Some of these numbers are not going to fall in line exact. You do the best you can with a scatter plot. It's hard to find a scale sometimes because the numbers aren't nice and perfectly in a row. So then we just plot our points. So let's just start plotting. So 119 is going to be there. 215 will be there. 313 is there. 411. Right now it looks like it's in pretty good straight line. 510. 6, 8, 7, 7, and 8, 5. So it's definitely not a straight line, but to be honest, it's really not that far off. So here's the tricky part, and this is going to be hard for me to replicate this here without the nice, perfect straight edge. What we want to do is we want to find a way to draw a line that's going to hit most of our points, as many as we can. But we have to think about, how do I draw that line without having too many above or too many below? And I don't want to force them. So what I don't want to do is just pick this point up here at the top, for example, and connect it to the line, the point at the bottom. Because if I did that, you can hopefully imagine that I would have all my points underneath down here. So don't just connect the first and the last. Don't just connect the first two that you see and hope, because then I'd have them all above. So you have to find some line that kind of goes through and tries to hit as many as possible. So what we're going to do, and hopefully I can do this as cleanly as I can, I'm going to draw one like this. Not bad. As my line of fit. Now I would say this one is not too bad. It's not a perfect straight line, which it should be. But this is going to be something where I think, if you look at this, you see 1 point above here. These two look like they kind of go through my line. And then this point and this point maybe are also just above. Down here I've got these two that are definitely below, with possibly this one if I had a real straight line. So not a bad line of fit. And we're going to find that a lot of us might have different lines of fit from each other, but we should be pretty close at the end when we write our equation. So now we want to write the equation. So what I'm going to do on this is I'm going to steal 2 points to draw my equation. Like I said, I think this point and this point go through my line. So what I'm going to do is use 2 points on my line, and we're going to use the points 5, 10 and 6, 8 to write my equation. Now, you can use this in both ways. You could try to use slope-intercept. I'm going to use point-slope. So because I'm using point-slope, remember, I need the m and 1 point. So for my m, I'm going to do 10 minus 8 for my numerator, and 5 minus 6 for my denominator, and I'm going to get 2 over -1 or a -2 slope. Then I'm just going to use one of the points, and I'm just going to use 5, 10, just because it's the first one in line, to write it in point slope form. So remember, point slope, which we just talked about last week, looks like this. So I'm going to leave the y, plug in the 10 from my y1, plug in the 2 from my slope, leave the x, and plug in 5 for the x1. Now I'm just going to simply solve this, which I could in theory leave. Most of the time we want to see it all the way done out. So y minus 10 is -2x plus 10. I'm going to add 10 to both sides to solve for y, which will turn this now into slope-intercept form, -2x plus 20. Now, a couple of quick looks on this. If I look at my graph, we say that we have a negative slope. This is clearly a negative slope, so if somehow I had a positive there, that would tell me something to look at. This is an important piece. So this is saying that our y-intercept is at 20. Well, if I follow this line up, it's pretty close to being at 20, and again, I don't have a nice straight line, but it should be hitting right about there, which looks like we're pretty good. So I would say we have a pretty good line of fit. Now, what is this good for? Now that we have the actual data, which are the blue dots, I can now use my equation to help figure out what do we think is going to happen in week 9? What do we think is going to happen in week 10? And in week 9, what I would do is plug in 9 for my x to then solve. If I wanted to know week 10, I could plug in a 10 to solve. Once I have this model that's a linear model, then I can use it to predict based on my scatterplot data. Then the last thing we have to talk about is, what is this word interpret? So interpret. So we certainly know our slope is -2. But what does that really mean? Well, when I look at the data and I think about the labels on my graph, the y-axis, which is my change in y's, is dollars minus sales. The x-axis are the weeks or my run, or the change in x's. So when I look at this, -2 over 1 doesn't just mean -2 randomly. We don't know what that means. It means we are losing $2 million per week. So basically our sales are dropping $2 million per week. I don't want to say losing. Maybe losing is not the best word. Losing means we're losing money. Doesn't necessarily mean that, I guess. Let's just say it's dropping. Sales are dropping $2 million per week. And then what about the y-intercept, or the b? The y-intercept basically means what was the initial amount of sales. So we had 20 million sales at release, which would basically be the opening night. We had 20 million in sales. That was the release date. So it's not just that the slope is -2 and the y-intercept is 20. So this is a quick look at scatter plots. Hopefully it's not too bad, not too big of a deal. Certainly graphing a table shouldn't be too bad, and just a matter of finding the right scales for your x's and y's. Placing that line of fit is very important, so we can use that model to help predict future events. If you have any kind of questions, please feel free to ask me the next time we meet.